Hi everybody, welcome to lab number 3. This lab takes us to the Sidmouth sheet, which has a fantastic example of a geological map that's dominated by horizontally bedded rocks. If you go onto the BGS website and find this Sidmouth map, you'll be able to zoom into different parts of it, or follow along using the PDF version I've created on Student Central, and you'll be able to see that the geology in this area is dominated by outcrop exposures which are pretty much perfectly parallel to the ground contours. Now, using this geological map, I've set you this question paper where you can answer these short answer questions with information and calculations based on the map and stratigraphic column. Most of the lab though will be taken up by drawing a cross section, which I've provided for you a hill profile. To save you having to draw one which would otherwise take you hours and hours, you can just plot your geology straight onto this cross section, and using those two things together you can discuss or try and understand the sequence of events that must have happened to the area in order to give you the geology as it is presented on the map and your cross section. So in the next section of the video I go through the steps of how you build a cross section for this area, and in so doing we'll answer some of the questions presented here. So I'll see you in the next part of this video. Okay guys, welcome to our first cross section from a real geological map. In this session we're going to be looking at the drift sheet for Sidmouth, published 1974, and I've picked this map first because it's the best example that I could find of really simple horizontally bedded rocks with some vertical features as well. There's not much really going on at all in this map other than these horizontally bedded sedimentary rocks. If you look at the stratigraphic column for the area, you can see that we have this conformable sequence of Triassic and Permian marls and sandstones that then give way into the Lias and the Cretaceous rocks, which go from sandstones and clays into Cretaceous chalks. On top of that we have an unconformable surface upon which the clay with flints, which are in part Eocene age, have been deposited. And then on top of that we have these alluvium and valley gravel drift deposits. So this is a really simple layer cake stratigraphy, one bed being deposited on top of the other. Really simple stratigraphy that hasn't been really folded or tilted, so that these rocks are still largely horizontal. Now you can tell that they're horizontal because of their outcrop pattern. If you look closely in different regions of the map, you can see that the outcrop patterns, the boundaries between the different geological units, easiest to see between the Kuiper marls, the Triassic Kuiper marls, which are in this salmon pink colour, and the green sand, which is in this green colour, or between the green sand and the clay with flints. If you look at those geological boundaries, you can see that they're parallel, or more or less parallel, to the ground contours. And whenever you see that sort of outcrop pattern, that parallel nature between geological contacts and the ground contours, that's evidence of the rocks having a very low angle of dip. They're more or less horizontal. Now, aside from the horizontal sediments, you'll see these thick black lines, which, if we look at the key, denote that these rocks have been faulted. Now, for the most part, these fault traces are quite straight. They're linear, they don't change in direction. And that sort of outcrop pattern indicates that these faults are quite steep. If the faults were perfectly vertical, then they'd just be a continuous line for their entire outcrop extent. And we can see, for the most part, many of these faults are extremely linear. Some of them have a bit more of a curve to them, which might indicate that they're at lower angle. But for the most part, we have these steep faults that have deformed the stratigraphy. But that's it. Other than those faults, everything is pretty much as it would have been when it was deposited. Now, what I've done is boxed the area that we need to draw a cross section from. I've got two little bits of tape which denote the two extremes for our cross section. And what we're going to do now is build ourselves a cross section which shows the subsurface geology between those 2 points. If we were to take a slice through the crust and look at it side on, what would the geology look like? Okay, so let's get started with that. I've got my tools, I've got a ruler, I've got a calculator, I've got my array of pencils and colours, I've got my protractor. So that's everything that I need really to get started. So tune in for the next bit of the video where we start building our cross section. Right, so now what we have to do is start collecting the data we need to draw our geological cross section. Now, we've already established that these rocks are largely horizontal. Those outcrop patterns, which are parallel to the ground contours, they indicate that the dip of these rocks is essentially zero. They're flat lying. So we're not really going to see much in the way of structural measurements. We're not going to see very many dips and strikes recorded on this map because simply the rocks don't have any dip. So what we can do is start collecting our data for our cross section. And what we do is use our strip of paper and then get it so the corners of that, or the edge of that paper, runs along the two extremes of our section. So this coordinate here is 270, 0, and this coordinate here is 190960. So those are that we want to see a line through the crust, through the subsurface between those 2 points, and we're going to draw that in cross section. So once I've got my paper lined up, I simply mark on the two extremes. So that's point A, and that's, oh, just moved it ever so slightly, and that's point B. So if ever I move this piece of paper, I can line it back up. And then what I want to start doing is, as I move along this transect, along this cross section, I'm going to mark on wherever I find a new geological contact. Now what I'm going to do is ignore the alluvium and the valley gravel. So the valley gravel is this sort of orange cross hatching, and the alluvium is this pale yellow. And the reason that I'm going to ignore them is because they're going to be extremely thin veneers on the surface. So when I plot them on my cross section, they're going to be thinner than my pencil line, so I'm just going to ignore them completely. The only rocks that I'm going to plot on my geological cross section are the Kuiper marls, the unit that's labelled F6, the upper greensand, which is this unit H4, the chalk with flints, which are this C with a little F inside it, and then over in this part of the cross section, the rock that I'm going to have to pay attention to are these rhyolitic beds, which are labelled FG. So whenever I go across this cross section, I'm going to mark on this piece of paper where I cross a geological boundary. Okay, so let's get started. I'm in F6, I'm in the upper Kuiper marls all the way to here. I'm going to ignore the valley gravel, but then I get into the greensand there, there. Then I'm into the clay with flints before going back into the greensand. Then I'm back in the upper Kuiper marls. Then into greensand. Bit of chalk with flints. Then into greensand. Then back into Kuiper marls. Then into greensand. Clay with flints. Into the greensand. Back into the Kuiper marls. I'm going to ignore that alluvium, that thin veneer, and then mark on the remaining contacts. There's those rhyolitic beds. There they are again. And there's my greensand to finish the section. Now what I'm going to do is, because at the moment I've just got these little marks, and if I move that I'm not going to know what these marks represent, which rock types are intervening. So what I'm going to do is colour a very thin strip on top of my cross-section strip of paper, just so I know what rock type is going to exist between the contacts that I've drawn. Now if you don't want to do this in colour, if you'd rather do this with labels, then you can do it both ways. But I find it just helps me remember what I've been trying to draw in my cross section. I think we're almost there. Now I just need some green sands. Bit of green sand, and then the last colour is my rhyolitic beds, which, oh, I've not got that one right. That one and that one. Let me correct myself there. Great. Then what you can do is, if you wanted to, you could then further label your cross-section strip to show what rock types you've got. So for instance, I've got the CF there, CF there, CF, the clay with flints. Then I've got the green sand, which on our stratigraphic column is H4. And you can see that I could continue that to label my cross-section strip as completely as possible. The Kuiper marls, I think they're all F6s. That's their symbol on the stratigraphic column. H4, and then the rhyolitic beds there, FG, FG. Okay, so that's this strip that I've now completed shows, if we were to walk along this section, where the contacts would be along that strip. Now I haven't crossed any other geological formation. It's almost as if I've picked these coordinates specifically. We don't quite cross this fault. It's just off the end of our cross section, so we don't have to mark that. And then I'm ignoring all of these thin bits of drift, this valley gravel and alluvium. If I was doing something more complex, I might want to give myself an idea of what the angle of these contacts are, but what I'm just going to do for these rocks is just remind myself that they're flat. Okay, there's nothing else really that I'm going to get from this. There's no other structural information, there's no other rock types, so I think at this point I can then take this data that I've collected and then start drawing our cross section. Okay, so this is our map that we're now going to draw our cross section on, and this is the hill profile which you've been provided between those 2 points. So if we bring our cross section panel back, the one that we created earlier, what we want to do is show how the geology that we've recorded, how that would interact with this hill profile that you've been given. Now this hill profile looks pretty extreme. It looks like some sort of dolomite terrain. But the reason that it looks so extreme is that I've added in a vertical exaggeration factor, which we'll work out in a little while. But the reason that it's been vertically exaggerated is because if you have a lot of flat-lying rocks on your cross section, they tend to bunch up as a series of parallel lines very close together, and they don't show you anything. So what I've tried to do is stretch that out so we can actually see some thickness on these beds. Okay, so what I'm going to do then is line up the strip of paper that I have made between A and B, the 2 ends of the cross section. And then what I'm going to do is mark on where these contacts would hit our hill profile. And the way that I'm going to do that is to just draw straight up to where that point along the section of each geological contact, where each one of those would hit the hill profile. Okay, now for this one you have to be dead certain that your cross-section line is accurate, that you've taken the time to mark the positions precisely, because when we have one of these vertically exaggerated cross sections, any kind of movement a few millimeters this way or that will greatly affect what the cross section looks like. So let's just take an extra minute to make sure that A and B are perfectly lined up, and then you guys at home who are doing this could use a protractor or a ruler to measure that precisely. So for example, if I wanted to mark on this contact, it hits the cross section there. Then using my protractor, I could put it right on that point I've just drawn. The crosshair of my protractor is on that point. Make a mark vertically up, and then I connect those 2 points. So right there, that's where that geological contact between the rhyolitic beds there and the Kuiper marls, that is exactly where this contact would hit my hill profile. Okay, so what we can do now is just spend a minute or two plotting where these contacts would hit our geological cross section. So there's another one there. There's one there, and this one would plot about there. I'm just trying to go as straight and vertically upwards as I can. Then we've got one that comes about there, and this one is about there. Then we've got this big expanse of clay with flints before we get to another one right about there. Then we've got one if we go vertically up to about there. Then that would be there. This one vertically up intersects our cross section there. This one going vertically up intersects our cross section there. This one going vertically up is about here. Here. Out there. Almost done. There. There. Next one going straight up to there. Next one going straight up to there. Straight up takes us to there. And there. So what I've just done is transferred all of the contacts from my cross-section strip onto my hill profile. Now what I can do to make myself feel a little better is, and it'll actually help me with my interpretation, is I can do exactly what I've done here by colouring in that thin veneer on the cross-section strip. I can colour a thin veneer along this hill profile. I think if I do that, particularly in this case, it'll really let me understand what's going on. Okay, so let's first of all colour in everything, all of my green sand, everything that's H4 as just a thin veneer on the surface. And what this is telling me is, you know, if I know nothing else about the subsurface, then at least I can tell you what rocks crop out on the surface, like right at the top. Which I guess for some people might be the all that you really need. Okay, so that's all of my H4s thinly veneered. Then let's go for our clay with flints. That's one clay with flint, that's another one, that's another one. This is another one. Any more clay with flints? No more clay with flints, but then what I do have is this Rhytic bed. There's a bit of it here. There's a bit of it there. There's a bit of it there, and then I don't see it again. And then the only thing that I've got left is the Kuiper Marls, that salmon pink unit. Just drawing that in as a thin veneer. And this one, and then I think we just have one more. Great, so what I've done there is just shown, if you were a happy camper going out for a walk and you were climbing this admittedly extraordinary looking terrain, you'd walk across the different layers of the geology, and each time the colour changes, that's showing you where the new rock type would be. Okay, now what we want to do is show where the contacts are in the subsurface. And in order to do that, we need to know something about the dip of the contact. And if we just refresh ourselves from going back to the map, you guys remember that from looking at the outcrop patterns of these rock types, you can see that those geological contacts are parallel to the ground contours, which means that these rocks have to be flat. They have to be flat-lying. They can't have a significant dip to them. And in fact, what I did for drawing my cross-section, I already made a note to myself that these rocks were flat. So all that I have to do then is draw these contacts to reflect their horizontal nature. So from here to here, I've got a horizontal contact, and there, and there, and there. And then for my contacts between my green sands and my Kuiper Marls, they're all horizontal. They're showing that parallel outcrop pattern. So we've got a horizontal contact there. Oh, we've got another one there. We've got another one about there. Then this one, and we've got a horizontal contact there. And then you see where these two contacts are between our green sand, that's horizontal. And then right at the tip of our cross section, that one's horizontal. Now we've got these horizontal beds between the clays with flints, the green sand and the Kuiper marls. But then what we have over in this area, which we don't have over in the western side of the map, on the eastern side of the map we've got these outcrops of the Ritic beds. So what we're able to do is put those contacts in as horizontal lines. We've got those, that one's going in there, that one's going in there. And that's all of our geological contacts. Now at this point, just to make sure, or to make us feel like we have made a success of things, we can colour in the geology between the appropriate contacts to show what rock type's there. So I've just picked up my green pencil, so let me start by showing you where the green sand would be. It's between our two contacts, between the contact with the clay with flints and the contact with the Kuiper marls. So we're almost getting there with the green sand. I've just shown where that is, and we've got these two little tops of these little hills. Then on top of that we've got these clays with flints, which are about just like so. They're capping the top of the hills around this Sidmouth area. Now it looks like on the eastern side of the area the topography never gets high enough to have these clay with flints to be preserved. It looks like on this side of the area we've been eroded down such that all of this is missing. Then we've got on this side, on the eastern side, we've got these couple of outcrops of Ritic beds. And then beneath those, forming I guess the base of our stratigraphy so far, or to the depth that we're interested in anyway, is just the Kuiper marls, this F6 unit on your stratigraphic column. So I'm just continuing over just to finish these ones off. Now, that's grand. So we've got a nice representation of our subsurface stratigraphy, but what we can do is maybe demonstrate that we know that the current surface that we're seeing is a product partly of modern erosional processes. So maybe what we could do is show or extend the geology above the surface to show what it would look like before it had been incised by these valleys, before it had undergone these modern erosion processes. So maybe what we could do is show some dashed lines to show what the sensible continuation of the geology above the surface, what that would have looked like between our horizontal beds, because remember all of these would have been laterally continuous beds which would have continued across the landscape more or less. But then the one thing that's interesting, which I alluded to earlier, is on this eastern side of the map area we've got these Ritic beds which crop out, but they don't on the western side. And if we double check back with the map, here's our cross-section box, and here they are. You can see these outcrops of FG, but you can't see this FG unit anywhere over here. So for whatever reason, back when that unit was deposited, it looks like it was continuous in the eastern side of the map area, but for whatever reason it pinched out so that it wasn't deposited to the west. So what I've done there to try and show what I think might have happened when the geology was deposited, I've tried to plot that as a thinning out horizon that disappears before any of this topography, because we can't see it there cropping out. Okay, that's our cross section, and now what we need to do is move on, I think, to the good housekeeping measures, giving this cross section useful scales, giving it a key so that people can understand what exactly it is that we've drawn. Okay, so the first thing that we need to do is give our cross section a horizontal scale. Now, if you remember, when we were on the map, all that we did was take the information from the map, transfer it onto this cross-section strip of paper, and then transfer that information back onto our cross-section. So we haven't changed the scale of the information. We haven't stretched it, we've just literally moved it from one piece of paper to another. Therefore, the horizontal scale of our map, of our cross-section rather, is exactly the same as the horizontal scale of the map itself. So our map, if you were to look at the base of the map, you could see that the scale is written as 1 to 50,000. So every unit, however long that unit is on a map, so for instance every centimetre on our cross section in the horizontal scale is equal to 50,000 centimetres in real life. So our horizontal scale for our cross section then is simply 1 to 50,000. Now, what we've done in making our cross section, we've stretched the vertical axis. We've given it a vertical exaggeration, and that way it's allowed us to see these horizontal beds. And now what this question is asking us to do is calculate what that vertical exaggeration factor is. How many times have we stretched the vertical axis relative to the horizontal axis in order to give us this topography? Well, on the left hand side of the cross section you can see that we've been given a scale. We've been given this 0, 100, 200, 300, 400, 500 meters scale. So what we can do is use a ruler to work out what the scale factor of this vertical axis is. So with using our ruler, if we put it against that scale, then I can see that this scale says that 1 centimetre equals 100 meters. Okay? Now if we try and work out what the scale factor is, what this 1 centimetre on our cross section is equal to 100 meters in real life, another way to say that is 1 centimetre equals 1,000 centimeters. What I've done there is just converted meters into centimeters, To do that, you multiply the number of meters you've got by 100, and that gives you the number of centimeters. So our vertical scale is equal to 1 to 10,000, and our horizontal scale equals 1 to 50,000. And to work out what the vertical exaggeration factor is, we simply divide the horizontal scale by the vertical scale. So we take that 50,000 to work out our vertical exaggeration is equal to 50,000 divided by 10,000 to give us a vertical exaggeration factor of 5. So our vertical exaggeration factor for our cross section is 5 times. So now what we've done is given our readers a horizontal scale, so you know what distance you're travelling along the cross section in this orientation, and we've told them by how much we've stretched, by how many times exaggerated the vertical axis is relative to the horizontal. I think the last thing that we need in order to finish our cross section off is to give ourselves a key. So what do these colours mean? And so what we can do on the right hand margin is give ourselves the right number of boxes. How many rock types do we have? 1, 2, 3, 4. Good lord, that's a very simple cross section, isn't it? 1, 2, 3, 4. Move it over a little ways. 1, 2, 3, 4. Turn those into boxes with a ruler. Don't do it by freehand, especially if you can't draw, like me. And then let's give those the correct colours. So at the top here, we've got our clear with flints, which sit on top of our green sand, which sit on top of our rhyolitic beds, at least in some parts of the area, and our Kuiper marls. So we can leave it as colours, but if we want to be accessible, then we have to accept that some people have a colour impairment, so we can give that box within it its own symbol. That's our clay with flints. This is our green sand. This is our rhyolitic beds. And this is our upper Kuiper marls. And then maybe what we could do is add in some of those symbols. So this is an F6, this is our H4, this is our clay with flints, and then maybe just draw a small arrow to show that those there are the rhyolitic beds. Okay, so let's go through our checklist. We've got the subsurface geology done. We've shown where its continuation above the modern weathering surface would be. We've given it a horizontal scale, and we've given our section a vertical exaggeration factor. We've got a key which shows what the rock types we've drawn on our cross section are in reality. I think for a first attempt at a cross section, admittedly for quite a simple place with simple stratigraphy, we can be pretty proud. Hopefully you guys, when you come to do this, you'll have something similar. But if not, feel free to re-watch this video as many times as you need until you get it down. I'll see you in the next video where we travel to Penrith, where we look at a cross section where instead of seeing these horizontal flat-lying beds, we're going to see beds that have been tilted. Okay, thanks for watching guys, I'll see you later.